quick mathematical explanation of calculating beat frequency. So hopefully you've seen what beats look and sound like in another video. To give you an idea of how we calculate the beat frequency of something, let's say we have sound 1 vibrating at a frequency of 440 hertz. By the way, 440 hertz comes up a lot in music. 440 hertz is musical note A4, which is kind of the standard by which you tune most instruments. So if you start at A4, you can then kind of figure out the entire music scale from there. And so a lot of people will just remember A4, 440 hertz. That's why it's stuck in my head, and you'll hear and see me use it in a lot of examples. And let's say F2 is another sound of frequency 500 hertz. If you play these two sounds at the same time, they will generate a beat pattern, which is shown here. And to figure out the frequency of those beats, and just so we're clear, the beats are kind of these big shapes you're hearing, so you'd hear whom, whum, whum, like that. We're not worried about the little in-between, and that could be confusing. So the beat frequency is kind of the big blobs that you see. And that can be, sorry I deleted too much, that can be confusing, because when you look at this, knowing what a wave looks like, you might wonder, oh, are we talking about the little kind of waves inside these blobs, or the blobs themselves? And it's the blobs themselves that are making the beat pattern. I've heard them called beat envelopes. I don't know if that's the real term. I have heard someone call them that before. But if you're looking at a picture and trying to decide what the beat frequency is, we're talking about how often these kind of big blob-like things happen. And those would be the whom, whum, whum, whum you would hear. To figure out the actual frequency of this beat pattern, you just subtract F1 minus F2. And it's not going to matter in which order you do them in. Frequency in this context can't be negative. In fact, I'm not really sure in what context frequency could be negative. But say if we did this subtraction, we'll get negative 60 hertz. Notice there's an absolute value symbol here. So you get 60 hertz. So we can't, it doesn't matter which one we pick as F1 and F2. And also if you were trying to work backwards, you couldn't tell which one was F1 and F2, because either way you arrange this, 500 minus 440 or 440 minus 500, you'll still get the same amount. So we're only worried about the absolute value, and that's the frequency of the beats, because I'm not sure what it would mean to have negative 60 hertz. Remember, hertz is just how many times something happens per second, so this is 60 of those beats per second. I don't know what it would mean to have negative 60 per second. Do you unhear them 60 times a second? I don't know. But that's how you do beats. You just subtract the two frequency, and that's your beat frequency. It's really that easy. This formula would not be given to you because it's more a fact than a formula. So you might want to take a second and just memorize it, commit it to memory. Beat frequency is the subtraction of the two frequencies and their absolute value. All right, let's look at this question, though. These are two beat frequencies. Let's read the question. The two traces below show beats that occur when two different pairs of waves are added. For which of the two is the difference in frequency of the original waves greater? Well, remember, the beat frequency is the difference in the two frequencies, F1 minus F2 absolute value. So this is really asking which one is the beat frequency greater, because beat is the difference in frequencies. So you might want to memorize that real fast. Difference in frequency is the beat frequency, because if you play them at the same time, you'll hear their difference as beats. Looking at this, it could be tempting if you were just doing the pictures to think, oh, well, I need to figure out how many of these little kind of wavelets are happening in here. But remember, the beat frequency is the big blob-like thing. So in a given amount of time, if we assume that both of these pictures show us, say, 1 second or one given amount of time, we've got 3 beats that happen over here, and we've only got 1.5 beats that happen over here. So if these were both a 1 second picture, this would be a 3 hertz beats pattern, and this would be a 1.5 hertz beats pattern, meaning that pair 1 has the greater beat frequency, meaning that pair 1 had the greater difference in frequency. All right, that's all. If you want to rewind a minute and a half or so, I think I crammed a lot of info into this little slide here. Could be nice to listen to it again. Otherwise, carry on.